Okay, we're going to break away from the Key book for just a little bit, and we're going to look at some of the same topics that finish up Chapter 7, but I want to do it from a different framework. I want to talk about what MySQL is like as a programming language, compared in contrast with something like PHP or Java, rather than just as extensions to SQL. I've broken this into 4 different parts just to keep the videos short because it's tough to go through a long video. This is part 1. This is kind of an overview of what we're going to be doing. Come on. Come on. There we go. SQL for programming. Not all problems fit into the SQL relational algebra paradigm. This whole thing we've been playing with the selects, and we have sets and we combine sets. And for some problems, it's extremely powerful. But for other problems, it's not a fit. One way around this is to combine SQL with a different language. For example, our use of PHP. Or most programming languages, including, say, Java, there's typically a library that lets you have a Java program get back a set from SQL, much like PHP gets back a set from SQL. There's a library called JDBC that I used a number of years ago in this course. That way you use a programming language like Java or PHP to what its strengths are, use the SQL to what its strengths are. Another approach, which we're going to poke at here, is to add programming constructs to the database engine. So instead of just limiting the database to the SQL relational approach, we put programming constructs into the database engine so that it develops its own higher level language. There's something called PL/SQL. PL stands for programming languages. In Oracle, there's something called Transact SQL that's used in Microsoft SQL Server and Sybase. Microsoft SQL Server has actually started its existence as Sybase. MySQL also has a similar programming language extensions, but they're not packaged separately. And a lot of that may be because MySQL has always been a free thing, a free tool, whereas the others, you paid for them and you paid extra to get the programming language. Like if you wanted to use Microsoft SQL Server, you paid, and then if you wanted to use that Transact SQL, you paid more. Whereas with MySQL, the whole thing was always free, and so I don't think they ever had the motivation to pull pieces out separately. Obvious sorts of extensions that we get are begin and end blocks and if then else case for selection and while and repeat for looping. So we end up with loops and ifs and begin end blocks, and so it suddenly starts to seem a lot like what you're used to in the way of programming language, and not this thing where you say, you go do the work to come up with this set and then give me the set. And that's good and it's bad. Mostly it's bad, but it also has its good points. The environment we execute in, the programs that we're going to write, are actually stored in the database, not off in the client program. And by putting them in the database, they can be accessed by multiple users. So we write it once, we store it in the database, and anyone that can get the database has the potential to get at our code. And they're controlled by the database access permissions. We've just started mentioning this, but one of the powers of a database is they put a lot of effort into controlling who sees what. We talked about this a lot recently. And just like we can put a permission as to who can look at a particular table or a particular view, we can specify who's allowed to run a particular program. And that can be very powerful. The programs execute on the server and not on the client. That means they're on the same side of the network as the data, which may well be more efficient, rather than if you put that logic into your client program, it may have to pull a lot of data over the network to operate on it. It might get a much smaller result than what it started with, and yet it's pulled all that data across the network to do its work. Whereas here we put the program on the same side of the network as the data, it can work with the data and just hand us back the possibly much smaller result. It also has the advantage that different clients are processed the same way. Maybe we have a web client and a Java program that's a client, and maybe we've got a cell phone that has an app as a client, and they're all doing something that calculates something. And with those different languages and different platforms, we could have all sorts of slight differences in results, rounding errors, for example. By doing it in a stored program on the database, all of those clients will end up doing the same result because they'll simply kick off the same code, get a result back, rather than having their own code. Also, we're not going to put a bug into one client and hopefully not another one. But if we can get the code right in the database server in the stored program, then it's right for all of our clients, no matter how different they are from each other. We keep in mind that programs, it's nice that they're out there on the server, and that could even be more powerful hardware than maybe a lot of our clients. And it's on the same side of the network. Those are all advantages. But keep in mind that programs are not as optimized as queries. Databases do a fabulous job optimizing queries. So we want to use the power of queries if possible. So for example, let's say we need to get some things and we need them to be sorted. With the constructs we're getting, we could write our own sort, like we could write a merge sort or a quick sort or a bubble sort, something like that in our stored code, or we could simply do an order by statement on our select. Well, the order by is going to be far quicker at sorting the database than pulling it into the program and comparing it in memory and variables and doing some kind of a sort. So whenever possible, we want to put our work into the selects, into the queries that we've seen, and try to keep it out of the stored program. But there's some places where we can't do that. Okay, so here's a little diagram of this. We see we've got our network, we've got multiple clients on the left side of the network, we've got our database server, and it has some storage on it. And the point here is that we've got different things stored in the database. Obviously, we have tables, several tables. We might also have views. I didn't put them on this slide, but we might have views as well. But we also have these stored programs like functions and procedures, and actually I could have added triggers as well. Triggers are also stored on the database, and we'll discuss how those work. But the thing to keep in mind is just these sorts of stored programs we're talking about, they're stored on the database server, not in the client. Okay, types of stored programs. And this is one of these areas where the different databases have gone kind of their own ways a little bit. There's more similarity than differences, but they're not as standardized as select statements or some of these other statements we've been using, which have become very standard. There's an ANSI standard for those, not so much for the stored programs. So these are the stored programs supported by MySQL. And we can have a function, and a function returns a single result. It can be used in an expression, and it's used in a select by the client. You've kind of seen some standard versions of these things like the count and the average and the maximum, things like that we've used as part of selects. We can write our own functions, and they'll be somewhat similar. They'll return a single result. They'll take multiple parameters, return a single result. We have a procedure. A procedure can modify tables, which a function can't do, but a procedure can modify tables. It can pass results back through parameters, so we can have multiple results that get passed up. We can commit and roll back transactions. We haven't talked about transactions yet, but we will. And we can't access tables and functions, but we can access tables and procedures, including doing commit and roll back transactions. They're called directly by the client. We have client code that says, call this procedure for me. Then we have triggers. Triggers are designed to modify tables, and they're not called by your client code. They're called by the database when an event happens. A typical example is we can put a trigger a trigger on a particular table, and when an action happens to that table, then the trigger code gets called automatically for us. The client program is not even aware that it's calling the trigger. The trigger just happens, okay? And it might happen because of something like an insert statement or some other type of SQL. So in general, we can we can specify one trigger for each table for each kind of event. So we can, for a given table, we can specify an insert trigger, an update trigger, a query trigger. That's about it. Then we have events. Events can modify tables. They're called by the database based on time. So we might want something that runs every night. Like if we're a bank, we might want to update people's accounts every night or maybe every 4 hours or something. It's something that operators tend to be involved in, and we're not going to discuss them further in this class. I just call your attention to the fact that they do exist. Okay, high level, function rules. What can functions do and not do? So functions cannot modify a table being used by the statement that invokes a function. They can be part of a select statement, but if we try to have them part of something that modifies a table, we can't also include a function call into that. They cannot use a select other than we'll see there's a special select called a select into that takes a value out of a database and it puts it into a variable. And so they can get some data out of the database using the select into, but that's their only use of a select. They may not use a transaction statement such as a commit and rollback, and they may not use a command to switch databases. You've seen that where we say use such and such a database. I can't wedge that into a function. It's considered to be too dangerous. They cannot use dynamic SQL. They can't build their own SQL statements, and they cannot be recursive. Okay, we don't do recursive functions in MySQL. Procedures. Procedure rules. Procedures have parameters, and those parameters can either pass information in, pass information out, or be an in and an out, which is we pass something in, we change the value, and it comes back out. We can use a select statement in our procedure. We can use transaction statements, including commit and rollback. We may not use the command to switch databases, okay? Don't use a procedure to switch databases. You can use dynamic SQL. You can build a string and then use it to work with your database. They can be recursive, but that has to be enabled. There's a keyword that's part of the procedure declaration that lets things know that it's recursive. If you leave that out, then you're not guaranteed to get the results you want when we call it recursively. That's intended to be a bit of a performance enhancement. People thought that they could write faster code if they didn't have to worry about recursion. And so the compromise was you can do the faster stuff, but the person writing the procedure, if they need it to be recursive, they can give you a keyword on there that tells you this is recursive, and then you have to do something slower, make their recursion work. Next, we have triggers. Triggers are called by the database engine when certain events occur, such as inserting a record into a particular table. The trigger is always associated with a particular table. It can be associated with an insert, an update, or a delete action. A trigger can occur before or after the table is affected. Now, a lot of databases, you have a choice of having your trigger happen before, having your trigger happen after, or having your trigger happen instead, kind of in the middle. MySQL does not support the instead version. It only supports before and after. So a given table can have one trigger of each type time combination for a total of 6 max. So for instance, I can have an update before and update after. I can have an insert before and an insert after. I can have a delete before and a delete after. Maximum of 6. What if I really need more than that? Well, I can look at doing something like declaring a view that basically affects the whole table, and then I can put different set of triggers onto that view. Now, whether those triggers happen or not depends on whether the view is used to update or whether the table itself is updated. You gotta be a little bit careful. Triggers do not have parameters. For an update or an insert trigger, the value's about to be applied to the database. Okay, so this is a before, it's about to be applied. So I've said this is a before condition. So what I'll do is I'll get the columns in. So let's say I'm inserting into a table. I'm going to get a bunch of variables that have the names of the columns, but they'll have the word new in front of it. It'll say new dot column name. Let's say I have a first name and a last name in my table. I'll have a new dot first name, a new dot last name, and those variables will show up with the value that the user is planning to update the table with. And my trigger, my before trigger, will be able to change those values if I want. I can write code that changes those values. So changing the value in a new column name will change the value stored in the database because it'll happen immediately before it's stored in the database. For a delete or an update trigger, the values that were previously in the database, there's no new here, right? I say delete this record, what would the new value be? There's no new here, but we do have the old. So for a delete or an update, the values that were in the database, they're about to be deleted or updated, can be accessed in your trigger by using the name old followed by the column name. Okay, old dot column name. So we don't pass values in there. The values we have to pass from someone. Who would that be? The trigger is being run by the database because of an action. How would it know what values to pass in? So it uses the values from the table we're going to access, either the values that were there that are about to be changed or the values that were there before we started changing things. Trigger cannot modify a table being used by a statement that invokes the function. Okay. Trigger may not use dynamic SQL. It may not provide output, right? There's no way to do a print. There's no way to do something like that. I think you can do it, but it depends on what you call output. Like you can do a select into and put a value into a variable. And you can try to do something with a variable. It gets a little strange. We may not use a transaction statement such as a commit or a rollback in the trigger. We may not use a procedure that has out or in-out parameters. So I have a trigger that I've written, and I also have a procedure that I've written. Can I call the procedure from inside my trigger? Sometimes I can call the procedure if I pass information in. I have parameters going in, but I can't use the procedure if I have parameters that pass information out of the procedure. Then they would be back in the trigger. Rules for SQL at this point where you could not put a trigger on a view. I think you can now. I could be wrong. Okay, so that's our overview. So we'll stop this recording session here and we'll go on to the next whack of slides in just a second.